We're entering into word problems with rational equations. What helps us with these word problems, if we can categorize them, describe them as different types of word problems, and look at strategies to solve them. This first type of word problem I'm going to call a distance, speed, time question. And so we're going to develop a strategy for solving all of our distance, speed, time question. Okay, the first thing we're going to do is set up a chart. In this question, the chart was already set up for us. But some questions, you won't have the chart set up, so you'll set up distance, speed, and time, and you'll set up a chart based on those values. Secondly, you're going to enter in the information that you know. So let's look at this question. The chart was made for us. Mario drove from Edmonton to Grande Prairie and back a distance of about 360 kilometers each way. Mario's average speed was 30 kilometers an hour greater on his return trip than on his trip out. Must have been going downhill. His total driving time was 10 hours. How fast was he going in each direction? So often these questions, when you read them, you will get a sense of like, I have no clue. I read the question and I get that sense, I have no clue. And if you don't have a system for solving these, they're not the kind of thing you can read the question and go, oh, I have an idea of what it is. No, you'll probably say to yourself, I have no clue how to do this. So we set up our chart. Step 2, we enter in what do we know. So here's our chart, distance, speed, and time. We're doing two things. We're going from Edmonton to Grande Prairie, and we're going from Grande Prairie to Edmonton. Do we know the distance? Yeah. Yes, that's something that we know. It's 360 kilometers each way. After you've entered the information that you know, you have to choose a variable. Usually we choose x, and complete the rest of the chart with only that one variable. And in order to complete the rest of the chart, you need to know the relationship between distance, speed, and time. So what is our relationship? Well, we talked about in a question before knowing that speed is kilometers per hour. So I always start off with that formula. My speed is distance over time. If I rearrange that formula, I could get time times speed equals distance to get the distance by itself. And I could get time by itself by dividing both sides by speed. So time is distance over speed. So we have three different formulas that are the same formula, just rearranged. Now we need to choose a variable to represent something, because we filled in our chart with what we know, that it's 360 kilometers in each direction for the distance. If we read the second sentence, Mario's average speed was 30 kilometers greater on his return trip. So if we choose the variable x to say on the way there his speed was x, what's his speed on the way back? X plus 30. And in order to fill in the time section, that's where we have to use our formulas. What is time equal to? time is equal to distance divided by speed. So if he traveled 360 kilometers at this speed, the time that it would take him would be 360 over x. And if he traveled on the way back 360 kilometers at the new speed, the time would be 360 over x plus 30. Once you have completed your chart with that variable, we've done step one, set up a chart, entered what we knew, choose a variable, and complete the rest of the chart. Create an equation from the question and solve. So all of this has been preliminary. We haven't even gotten to writing an equation out yet or attempting to solve it. So we have to look back at our original question here and say, is there information in here that helps us write an equation? What information haven't we used yet? We haven't used this. His total driving time was 10 hours. We've got our time in our question, so we can say that this time plus this time has to equal 10. So we can create our equation, in this case, 360 over x, which was the time it took him to get there, plus 360 over x plus 30, which is the time it took to get back, equals 10 hours in total. And this is a rational equation. So now we can go about solving our rational equations like we've done before. We get our common denominator. So this one's missing x and x. This one's missing x plus 30 and x plus 30. And this one is missing the x plus 30 and the x. What do we get in the end? Well, our denominators now, since they're all the same, if you multiplied by x times x plus 30 on both sides of the equation, they would go away. And we get 360x plus, what is this? 10,800 plus 360x equals 10x squared plus 300x. It's a quadratic, so we make one side equal to 0, combine our like terms. 720, move that over to the other side, minus 420x minus 10,800. I can factor out a 10, x squared minus 42x minus 1,080. This is not easy to factor. We'd have to figure out two numbers that multiply to give us 1,080. You got it? You could use a quadratic formula since these numbers are big. Let's see, 1,080. That works. 1,080 is 60 times 18. And it would have to be negative 60 plus 18. So solving for that, you get x equals, well, you'd use a quadratic formula in this case. This would be calculator because the numbers are so big. Okay? So we get two possibilities. X equals 18, negative 18, and x equals 60. What did x stand for? Speed. So we also, in word problems, we have to also think about realism. Can you travel negative 18 kilometers per hour? Yes. You go backwards around the whole world and end up in, no. So that value doesn't make sense. The only value that does make sense is 60. Now we solved for x. What did the question actually ask us to solve for? So it just said choose a variable. Okay, determine Mario's average speed on each leg of his journey. So we should write a statement saying, on the way there, see, he traveled 60 kilometers per hour on the way back. He traveled 90 kilometers per hour. So chances are Mario rented a car, was from the United States, and thought the speed limit was 60 miles per hour, but hadn't figured out that his car was in kilometers, and drove 60 kilometers an hour all the way there. But then on the way back, he realized he could drive faster and did 90 kilometers per hour. So it took 6 hours on the way there, 4 hours on the way back, 10 hours total.
Will we ever have to work with different measurement systems, in the same question? Miles and kilometers or miles?
It could be, but mainly they'll set it up so that your units are all the same.